Hi, dear friends, welcome again. Now, let's look at the software testing. Once we write the program, while testing, it may fail. We see a failure, a symptom of a failure. It says that the fatal error program will now terminate. But then we observe that the program has failed, but we do not see the bug. This is the symptom of a failure. By testing, we identify the failure. If there is a failure, but we do not really see the bug or the error which had caused the failure. For that, we need to do a debugging to identify the bug. So it is important to see here that when we run a test cases, we see the failure. We do not see the bug. A failure is a manifestation of a bug or a fault. There was a bug in the code, and while running that manifested itself in the form of a failure. We do not see the bug, but we see the manifestation of it. But then we must also remember that even if there may be a bug, it may not lead to a failure. For example, the data that we give does not lead to the error to express itself. We are saying that initially errors and faults were synonyms. But then later the IEEE standard said that there is a difference between an error and faults. That will help us to express the ideas better. The faults or the bugs are caused by the mistakes or errors on part of the programmer. These create faults, bugs, or defects, and this is in turn cause failures. Now, so I represented that in this diagram above. The programmer here manually does many activities, specifications, designs, code, programmers, and can commit mistakes or errors. They can commit many mistakes or errors during the specifications, design, code, and but not all the mistakes become faults or defects. For example, let us say the programmer was writing a code I is less than 50, and by mistake or the error wrote I is less than 500. But then in the program there is a no way that I can get a value more than 50. Therefore, even though he made a mistake or an error, this does not become a fault or a bug. So only some of the errors become faults and defects or bug, but then some all the bugs they do not result in the failures. Maybe the test data that is normally given do not cause these bugs to express, and some of the bugs they cause failures. So can say that the mistakes or the errors on the part of program, some of them cause bugs. So we can say that the mistakes or errors on the part of a programmer, some of them cause bugs or faults, and some of the faults cause failures. Now let us look some facts about the error. Even the most experienced programmer do mistakes or errors. A typical industry average is 50 bugs per 1000 lines of source code is what good programmers make. Testing reduces the number of bugs. After thorough testing, about a 1 bug per 1000 line of a source code still remain. Even if we have tested a program very well, still there may be 1 bug for the thousands line of source code. But what are the origin of all these different bugs? 60% can be traced to specifications and design, and about the 40% from the code is average figure. This is just a lighter moment, a cartoon that holds a message here. This is the Dilbert cartoon from the Dilbert.com. So this is an engineer. He's the Dilbert. He's giving a presentation. Says, "I found the root cause of our problems. It is a people. They make mistakes. They are buggy. And just see here, the manager said, "Did you bring a pen?" So he has already forgot to bring a pen. So he made a mistake. So people forget and they make mistakes. Even the very experienced people they do mistakes, and that is the reason why there are bugs in a code. So assume that the best programmers make mistakes and they lead to bugs to the code. how do we reduce these bugs? Because finally we had to give a good software to the customer. There are many techniques to reduce bugs. One is to do is the review. We can do a specification review, either a design review, code review, and that is the very effective way to reduce the bugs. And testing is the widely practiced and acknowledged to be a good techniques to reduce bugs. Formal specifications and verifications are not used for all the part of the code. These are the expensive and difficult to use and cannot handle large programs and so on. Therefore, their use is testified use of proper development process. This is the defensive mechanism and it reduces the number of bugs. So the first question that needs to ask is that how do you test a program? Somebody may even ask you this question that how do you test program? We test a program by giving some input to it's called as the test inputs and then observe the output. If the output bit matches with our expectation, we say that the test case is passed. But is it had failed or we note down for which data is failed and under what conditions? So input data to the program, observe the output and check if the program behaves as expected. Give input to the systems, observe the output and see if it is the exactly as per our expectation. Then that is passed and but there is a discrepancy if there is a failure and we note down the conditions that is what input we gave under what conditions. So if the program does not behave as expected, we note the conditions under what it failed and this we call as the test report. This test report based on the test report debugging done to identify the exact faults or the bugs and then these are corrected. So for a typical program in an industry scenario, testing consumes the largest effort among all the development phases. It also has the largest manpower. So if you talk into any organization, you will find that there are more numbers of testers than that of designers or the coders or those who do specification or the analyst. Since the industry needs a large number of testers imply more job opportunity. Typical estimate is about 50% of the development effort is spent on the testing because finally we are need to give customer a very reliable software. If we deliver a software which is buggy, the company will get a bad name and the company cannot progress. So the most companies are careful about testing. They spend about 50% of the development effort in the testing. But testing is done towards the end of development life cycle. Only 10% of the development time is typically taken to carry out the testing. But how is 50% of the development effort spent on 10% of the development time? The answer is that there is a lot of parallelism in testing. Many testers can carry out the work the same time. Different parts, different tests, they can execute different test cases and so on. Therefore, using a large manpower, the testing time is reduced, but there is a less parallelism in specification or design because their work is dependent on each other. We cannot really parallelly deploy the 100 designers or 100 analysts doing the specification. Over the years, testing is getting complex and sophisticated. The reasons are that the programs themselves are becoming larger and more complex. Newer programming paradigms and test automation, there is a sophistication you must know how to use the test tool and also newer testing techniques. Many new testing techniques have been developed recently, and the testers must know these testing techniques. Those who do not know this, they think that testing is not challenging. But over the years, testing has taken a center stage and it has become much more challenging than even coding, designing, and specification. The reason why these perceptions exist is that in the early years of testing, testing was done by the inputting a random test value, which is called as monkey testing. Because of the large number of testing techniques and test related innovations tools that have come into the picture, monkey testing is no more used. And the testers have their own domain knowledge, and not everybody can do the testing. And they must also be the convergent with the test tools. In the initial year of the testing used to be called as a monkey testing. Basically given input data and observe it and anything happens. There were two types of monkeys. Initially the dumb monkey and the smart monkeys. So the dumb monkeys, they understood very little and just kept on typing in given data. Whereas the smart monkeys, they knew that how the software works, what are the menu choices, what is a menu choice need to do. They can execute specific scenarios and so on. So the dumb monkeys could only crash the system. That is the only thing that they can notice. Whereas the smart monkeys know what data is expected and so on. Therefore, is a much more effective tester. But then the both the monkeys, they give random inputs. The problem with the monkey testing is that if the random data is given, many parts of the program do not get tested. The risky area of the program are not tested well because they just give random inputs and not identify the risky area and try to test those. And also the worst thing is that many times they just say that the program failed, but they cannot identify why. What they have been doing, they cannot reproduce a failure. So this is the another basic concept, and that nowadays the effort is spread over the entire life. In the waterfall model, the testing was done towards the end of the life cycle, but now it is spread over the entire life cycle. Define and conduct unit testing, define and conduct integrate testing, usability testing, user acceptance testing, and so on. But another basic issue, another basic issue that we must understand before we look at the test methodology, then so on, is to test how long. Started to test as we test more and more, find some failures and so on. But then when do we know what to stop testing? Any what is the criteria to stopping at testing? One way is that as the failure reduces, we test, let's say that we test for 2 days, and if we do not find a failure, we will stop there. So that is one way. The another way is that the manager can seed some bugs, and then as the testing proceeds, you will identify whether all those seeded bugs have been found out. For all those bugs have been found out, and we will say that the possibly the other bugs could have also been found out, and that is the time to stop testing. Now we end this lecture, and now we will continue in the next lecture. Thank you.